Okay. All right, so I guess we're at time. We have a large crowd present, so we'll press on. Good afternoon, good evening, whenever you are. Welcome to the late session from IETF 120. My name is Stephen Farrell. My co-chair, Militia, is remote, waving to you there. As usual, kind of note well, you've probably seen this today already and yesterday, and you'll see it for the rest of the week, so we should be familiar with all this stuff. All the IPO rules, be nice to each other. We haven't had a problem in this working group so far on that, so I'm sure you'll continue to behave well. And note really well, be nice. So again, I don't expect an issue because we're not too controversial these days, which is good. For in-person participants, please sign in. You can use the on-site tool. If you're remote, please make sure your audio and video are off unless you're presenting or are making a comment in the queue. If you want to make a comment, please do join the queue, even if you're present in the room, so that we can help it. And a headset's recommended. As you can see, Militia's being very good. There's some links. We'll come to the agenda in a second in a slide. We have note takers. Thanks, Giovanni, and thanks, Marco, who's remote. For notes, we only need kind of actions and things. We don't need a blow by blow, but feel free to type as much as you like. Brief is fine. And Militia, do you want to talk about this fine event you had?
Yes, so here is a quick update on the event that we had in Paris in May, in between the Vancouver and Brisbane meetings. So because, as you could see from the announcement of the event, because many of the LA community is based in Europe, we organized a hackathon that was very well attended. We had more than 35 participants, 9 projects and more than 14 side meetings. We kind of mimicked the IETF hackathon setup at INRIA Paris premises in France. The event was very successful. We had so much fun, and we are looking forward to the next IETF in Dublin, where I guess most of the community will be meeting again in person. Next slide, please. So in terms of the adopted drafts in the group, so we currently have 2. The new one is Marco's ad hoc implementation considerations draft, which was adopted on 3rd of June 2024. It was resubmitted as draft IETF Lake implement cons. Mark will be giving an update about it during the meeting today. And then we have the Lake odds draft, which is in its 0.2 version, to be discussed during today's meeting as well. So these are the 2 adopted items that we currently have, and we have a number of individual submissions that we will be discussing today, mainly on remote attestation over ad hoc and pre-shared key-based authentication method in ad hoc. With that, I guess we can get to the agenda. So this is what the proposed agenda looks like. If anybody would like to bash this agenda, now is the time. So please speak up.
Nobody wants to bash the agenda?
Nobody wants to bash the agenda. So we stick to the proposal and we proceed with the first presentation, which is Joanna, I believe. Yeah. All right.
So you can just tell me when to go to the next slide. I don't think the clicker is going to do it with my computer. So.
Okay. Hello. Okay, so this is Giovanni, and I'm going to present updates on the draft lightweight authorization using ad hoc. Next slide, please. So I will give a quick recap on the protocol and speak about some merged PRs, and then spend some more time talking about a new proposal, which is advertisement of the Lake odds capability, and then ask for input from the working group. Next slide, please. So to give a recap, so we are proposing lightweight authorization using ephemeral Diffie-Hellman over COSE. Sometimes we call this protocol just ALTS, or also just zero-touch network join. So maybe I'll use these terms during this presentation. So we have 3 main entities: a device, a domain authenticator. Sometimes it can be considered just like a gateway in IoT contexts, and an enrollment server, which can be analogous to a manufacturer server. And we will be referring to them as U, V, and W for brevity. And the idea is that the device wants to join a new domain, and but it doesn't have information about the domain, only about the enrollment server. So it will ask for a voucher, and then the domain authenticator, V, will ask to the enrollment server if this device should be allowed to enroll or not. And the idea here is to allow a flexible provisioning. And this works well if you have many devices that you want to deploy and you don't want to provision each one with for each different domain. You don't have to connect to each device and provision different credentials because all the information that is relevant is exchanged between the device and the enrollment server. And something important, we are using ad hoc between U and V. So the link here is constrained between the device and domain authenticator. So next slide, please. So for a brief set of updates from the version number 1, now we are in number 2. So we merged an explanation with more details on how the error handling happens between the domain authenticator and the enrollment server. We have some updated references now that ad hoc was published as an RFC. We also addressed the extensive review sent by Marco. Thank you, Marco, for that. So we had some editorial updates. We specified some missing co-op status codes. We updated the name of one section. And most importantly, we clarified about the credentials, because before we were referring throughout the document to some certain kinds of credentials, for example, only using CCS for authentication, but that is specializing without the necessity. So we made it more broad. So this was a good change. We also had some small updates on CDDL definitions, thanks by this PR by Karsten, and also another PR by Joran on a read-through. And that's it, basically. Next slide, please. And now I'll talk about a proposal about advertising support of the Lakeouts protocol. Next slide, please. So to give some context, so at version 0.0, we identified one problem with the protocol is that sometimes a device U may try to join several times until it finds a suitable V. And why is that? Because, for example, in the enrollment server, there may be a policy stating that a certain device should only join by via certain V, or a certain gateway, or a certain set of gateways. So if the device doesn't know which gateway, it might keep trying and retrying to enroll until it finds the correct one. And this can consume time and energy, which are resources that we don't want to spend on battery-powered devices. So we proposed a solution for this, to use hints that would be shared between U and W. But then we run into some issues, mainly the privacy of sharing these kinds of identifiers that I will not go into detail here, but we had problems with sharing this information around. And this would also increase the message footprint for the protocol. So we tried to think of something alternative to that. So that's next slide, please. So what we are looking for now is to have a way to advertise the support of Lakeouts in a similar way to what can be done today. For example, when a Wi-Fi network advertises support for EAP, for example, with a flag for 802.1x for AA pole connections. So for example, we want to have that V, or the gateway, can tell you, the device, about the support of the lakeouts protocol. And for example, this can be done by having V sending a piece of information, we are calling it V info, to you. For example, it can convey that V supports lakeouts, or then that V is part of a particular system. For example, here, acme.com. And the idea with here is that is the same that I proposed. The goal still is the same, so is to prevent that the device will unnecessarily keep retrying. So we want it to just go directly, or have better chances of trying to join via a suitable V. And then the question is, how exactly what is the best way to do this, which is on the next slide, please. So for now, we have two approaches that we think may work. So one of them is based on layer 2 beacons and the ad hoc forward flow. And the second one uses co-op anycast with a unicast response and the ad hoc reverse flow. So I will detail each one on the next slides. For approach number 1, we consider layer 2 beacons and the ad hoc forward flow. So we have, I'm only representing entities U and V here on the diagram on your left. So what we have is that I add these two first arrows. They are not part of the original protocol. So the idea is that we leverage layer 2 to carry the information about V in a beacon, what I'm calling a layer 2 beacon that is carrying V info in the picture. And optionally, this may be preceded by a L2 discovery message. This is needed in some layer 2s. So we make some assumptions here, or we have to make some assumptions here, is that the layer 2 can be extensible at the beacon level. So for example, this can work at IEEE 802.15.4, which includes extended beacons that can be added, or also raw Bluetooth Low Energy, which is a technology that we use for a certain deployment at INRIA, for example. But this can require profiling at certain layer 2. And this approach also requires trigger packets, but again, it depends on the kind of layer 2, if this trigger packet is needed or not. For example, in non-beaconed IEEE 802.15.4, this kind of packet is needed. And we are keeping the use of the ad hoc forward flow, so it doesn't change the current state of the protocol. We already have something like this in the draft, which is in the CodeGP appendix, which already considers a discovery process, with the difference is that we are adding here the V-info information to be carried. Next slide, please. And now I will present approach number 2, which is about using co-op anycast response. But here we use the ad hoc message flow. So see that now we have 4 messages. So what happens is that U and V, U keeps being the client and V keeps being the server, but now U is the responder on ad hoc and V is the initiator. So first, the client, U, will send a co-op discovery message as unicast. And this message is not ad hoc yet, and it will be received by V. And then if V supports lakeouts, it will respond. If not, it will simply drop this kind of packet. Then upon receiving this, V can send back a message to you, again with the V info that we have been discussing. But what happens is that V can already compose a message 1 and initiate ad hoc exchange. So that's why we have the ad hoc message flow here, because V is composing message 1. And then this is sent to the device U, and then the voucher info, which corresponds to the enrollment request, is sent on message 2, and then message 3 will contain the voucher with the response. So with this, we also have some assumptions where we assume that layer 2 allows transporting packets before the enrollment takes place. So for example, this can work with raw BLE or even Bluetooth Low Energy with generic attributes. And this also works as an automatic filter, as I said in the beginning, because if V doesn't support lakeouts, it will simply drop the co-op anycast request. And of course, we are changing here more parts of the protocol because we are using the ad hoc reverse message flow, where U is the responder and V is the initiator. And message 1 is carried in the co-op response, and V info in the EAD1, and so on and so forth for voucher info and voucher. Next slide, please. So now for some discussion and impacts. So just summarizing basically points that I spoke throughout these two approaches. So with respect to layer 2 profiling, number 1, so approach 1 requires updates in beacons to carry V info, and that would require 1 profile per layer 2 technology. And approach 2 may need or may not need layer 2 profiling, as co-op messages can be just sent as payloads, so all the definitions can be made once in terms of what will be these co-op messages, and then if they can be sent as payloads, then it's easier. Then next, approach 1 is a smaller change because it doesn't reverse the ad hoc message flow. Approach 2, on the other hand, allows for ad hoc message 1 and V info in the same packet, so it can be a little bit more efficient. But again, it requires co-op communication before enrollment, and approach 2 uses the ad hoc message flow. And one question here is, if we think as a group that is it commonly deployment as the forward flow, do we have any consideration on that? And what impacts do we have it on implementations? And also, if we use this flow, we have stronger identity protection for V than U because we reversed it, as described in the ad hoc RFC. And approach 2 also offers better protections for some fields. For example, voucher info is sent in the clear in approach 1 because it's on message 1. But then in approach 2, it will be confidentiality protected. And similarly for the voucher, it's only confidentiality protected in approach 1, but confidentiality and integrity protected in approach 2. So those are the main points that I see so far, and I'm looking forward to input of the working group. And that's it. Thank you.
Cool. Thank you. So thanks. I mean, I think the discussion leading to this was interesting. So I'm grateful that people are willing to kind of consider these kind of potential privacy issues and see if there are good solutions. So yeah, now's a good time to jump in the queue if you want to discuss this. I think it's a good thing to discuss. And we have Christian.
Hello, thanks for this update. Two points or questions. One is, do you envision using co-op over GET for the approach 2? Because that does not trivially support any form of anycast. So if that's a requirement, or if that is something that you want to use, I think it can be added, but we should talk a bit more about that.
Okay, that's true. That's a point I have not considered about anycast and Bluetooth. Okay.
And a related note is that if you're going with version with approach 2, then it might be an option to send a bit of data in the Bluetooth advertisements that are broadcast by the device, and then this would not necessarily be a co-op message 1. This could also just be a kind of layer 2 basically a layer 2 information sent by the device, and then the ad hoc messages would be as in approach 2, but it would not require the use of the reverse flow, but the RTV could be the co-op client in that case. So I think this might be a bit of a hybrid thing between 8.1 and 8.2, but I think that could work well, especially with very constrained devices that work better as a server.
I see. Yes, that could work. I think only I really don't know how. So the hard thing for me now is selecting, because we have a few approaches that can work, and how you can decide on which one we think will be better, because we have many options.
So I guess the question is, does this have to be a single choice, or could you give kind of implementation guidance for, say, if you're in this scenario, then A1 is better, or in this scenario, A2 is better? Is that a feasible kind of outcome, or?
It can be a recommendation, but I think we should strive to specify as much as we can, but for interoperability. But
sure. So I guess, I mean, in this case, I think V is unconstrained, more or less.
yes.
So it could implement, if we had two approaches, it could do both relatively straightforwardly.
Yeah, that could be. Yeah, it's a good point.
Yeah. I mean, I don't think we need to decide it right now, but I'm guessing you would like to get this finalized soonish.
Yes.
Right, because it could impact on a lot of the rest of the draft and so on.
Mm-hmm.
Yeah. So, do we have other inputs from people who are remote or are present in the room?
So we have input from Joran, who thinks that both options can be supported depending on implementation. Also consider that identity of device is not protected in the A2 option. So I'm just relaying from the chat.
Mm-hmm.
Which I guess if V was somehow a person carried thing, or in your vehicle, then in that scenario, broadcasting the info mightn't be great.
Sorry.
If V was part of your car,
okay,
then being willing to broadcast might be a bad idea at that point. Depends. Seems a bit unlikely, but it could happen, I suppose.
Yep. Yeah, I think so.
Okay, so I guess for this we just want to start up with kind of a thread on the mailing list and try and resolve it that way.
Yeah,
probably the simplest thing. But I mean, I think if it's the case that V could, implementations of V could support both options, and then we can give some guidance as to how to do each one, that might be sufficient for interoperability, I think. Given that this is an optimization. So, right?
Yeah. It's true. It's and all the advertisement thing, as I see for now, it's optional as an optimization.
Right.
Yeah, that could be. Yeah, that makes sense. So I already sent an email to the mailing list. So whoever is interested, I welcome to comment.
Great, and so we should kick the discussion if it doesn't warm up.
For sure.
Okay. Cool, and I think that's the main issue with this draft that remains outstanding, right?
Yep.
Okay. Any other comments on this draft or on the topic? Okay, so we'll take it to the list and try and get it resolved in a timely fashion.
Yep, excellent.
Okay.
Thank you.
Great, thanks. I think Marco is next.
Yes, hi everyone.
I'll give you control of the slides, Marco.
Yes, please. Thank you.
So
hello everyone, this is Marco. This is an update on this working group document on implementation consideration for EDOC. Yeah, like Manisha mentioned at the beginning, it was adopted a month ago or so. We are in version 1 now, and the scope is unchanged, of course. It's about giving guidance on the implementation of EDOC and EDOC library, or the use of EDOC by an application. So rightly doing so, the EDOC RFC didn't focus on some implementation-specific aspects, focusing on the protocol in itself. It was deemed useful to have instead a separate document like this one, providing guidance for implementers on different aspects. And those covered until version 0, the adopted one, were basically these 3 ones on what to do. In principle, if EDOC sessions, derived application keys, or both become invalid, how an EDOC peer can behave in terms of learning on the fly or not, new other piece authentication credentials learned during the EDOC protocol execution, and side processing, branch side processing of incoming EDOC messages, mostly on 2 aspects: the fetching and validation of authentication credential of the other peers, or the processing of UID items, and sometimes the 2 things go really hand in hand. Okay, so some updates from this version. The main one, I think, was adding this new section 5 with considerations on using ad hoc with co-op and with the co-op layer fragmentation, namely blockwise. And this content builds on an appendix from the ad hoc RFC, giving the first definition of using ad hoc over co-op with the two possible message flows. But it builds also on a document from the core working group now with the RFC editor that continues with more details on the use of ad hoc with co-op for keying OSCORE, and especially proposes also an optimized execution of ad hoc, where thanks to a combined request, it is possible to use only 2 round trips to both complete an ad hoc execution and make a first OSCORE protected data exchange. Thanks to that. So putting all this together using the original or the optimized workflow, it is possible to take advantage of the blockwise fragmentation of the co-op layer, or sometimes you really need to. And it's good to have some considerations about that, and especially when it starts being inconvenient or to lose some of the expected advantage. And these sort of considerations used to be, until some point, part of the core document until we realized well enough that it was too much implementation specific or related. It was good to take it away. That we did. And now it's coming back here as indeed considerations for an implementation. So the details are in the draft, of course, but it's mostly about these 3 aspects. In case there is a wish to use the optimized ad hoc workflow beyond supporting it in itself, of course, without pre-requirements in terms of mostly message size limit, if blockwise is used and available or not. A sort of high-level comparison of performance, mostly in terms of round-trip times for completing ad hoc, and then a follow-up first secure data exchange in different situations. So depending on the size of the original data body to fragment and the size of the small block fragments, using blockwise or not altogether, and using ad hoc with the original workflow or the optimized one. And an interesting takeaway, I think, is a comparison in terms of round trips in case blockwise is used. Considering first a case where the use of blockwise is not specifically triggered by using the optimized workflow, and in that case, that workflow is indeed convenient. It gives you better performance and 1 round trip time less. Or yes, there is a corner case. Blockwise may be triggered specifically by the use of the optimized ad hoc workflow and that combined request. And in that case, the optimized workflow is not better anymore in terms of performance. It can still be as good, at least in terms of round trip time, but there's even a risk that it performs worse. So it's good for the application, and it is totally possible to do that, to perform an early sanity check before rushing, because it may be just overall inconvenient to run this optimization that becomes in principle conducive to worse performance. So that's one addition. And another addition is related to the trust models that an ad hoc peer can rely on for learning on the fly or not credentials of the other peer. We had 2 policies defined already, trimmed down to 3 that we had until some point, if you remember. And building on that topic, I started a new section 3.1, describing some particular details of what this means, what this process becomes in this particular situation when ad hoc is run as part of a transfer profile of the ACE framework for access control, the ad hoc and OSCORE profile. So in that framework and in this profile, you can issue an access token expressing access rights for one of the ad hoc peers, the ACE client. The token is supposed to be uploaded at the other peer, acting as resource server, and the token includes the public authentication credential of C to be used in ad hoc. There's a traditional way to upload the access token on the RS historically, but that profile is also defined in optimized way, where the access token is conveyed in the ad hoc execution by means of an EAD item. So in that case, and typically the first ever issued access token for that pair of peers, C and RS, is going to include the authentication credential of C by value. The RS may well end up learning brand new the credential of C without ever having seen that before, without having it stored yet. So practically for this to work smoothly by uploading the access token in an EAD item, learning should be really the learning policy on the resource server. And there's this sort of consideration about this topic now in this section 3.1. And finally, we have most of the draft already pretty well covering. I hope already the main expected behavior and steps to perform for processing incoming ad hoc messages, also in terms of site processing, mostly for, again, authentication credentials of the other peer and the EAD items. There may be also some particular situations, for now I call them that way. So I started the section about that, where more details can be provided on the processing of ad hoc messages. And to be a bit more concrete, I considered, again, the case that I mentioned in the previous slide. In this particular subsection on the ad hoc endoscopy profile of ACE, is mostly editor's notes for the moment, where for now I plan to cover mostly how to enforce the learning policies, and in case the no learning one, if the RS has a strong reason to enforce that anyway for that resource, and basically the possible upload of the access token in an EAD item under this combination should fail. And it's important to note and guide on how that can practically happen on the resource server. And you may also want to perform some sanity check and cross-check between the authentication credential as indicated by value or by reference in the ad hoc message as usual, and also in parallel instead in the EAD item if that optimization is used. It's all a bit provisional now, because depending on how much this is real implementation specific, it is indeed more appropriate for this document. If we realize it's something already important to say for the ACE profile in itself, probably that particular content can be moved out to the ACE document. But early to say at the moment, and I just prefer to start sketching this here. So for now, I only have this particular situation in mind, that profile of ACE, but this new section 4.4 can be the right venue to collect similar situation-dependent details. And I'm thinking, of course, of the other two documents that we have around in Lake, so outside and RA. Please do provide input, and in case we can start a new subsection on more particular situations. So this is the outlook on how to continue. I plan to mostly build up on those editor's notes I mentioned in the previous slide. I would like to have an appendix collecting certificates or other authentication credentials that can be just taken as is and used for testing. And a good starting point is something that we have already in the traces RFC, but I like to have more security considerations, of course. And again, people working on the implementation of ad hoc in itself, the original protocol, or use cases based on those. And again, outside an array, most likely, please do chime in, and we can arrange additional subsections with considerations specific on those cases. Thank you very much.
Thanks, Marco. And within a second of the 10 minutes, well done. So I guess this document proceeds along as you described. Any comments or questions on this right now? Okay, so in that case, I think we can move on to the next one. Thanks, Marco. And as Marco says, please comment on the list. And next is Yuksha. This is attestation, correct? Okay, and I pass you control of the slides, Yukshan?
Yep.
You should have that.
Thank you. Yep. Okay, so hi, I'm Yuxuan, and the draft is about remote attestation over ad hoc. So a quick recap of the initial version at last IETF. So we defined how to perform forward attestation in background check model. And one use case for it is that when an IoT device needs to attach itself remotely to a server for network access or onboarding check. And we also define 3 EAD items to complete the process over ad hoc. So the message flow is like the attester starts the remote attestation by sending an attestation proposal in ad hoc EAD1, which is a list of like all the evidence types that the attester can support to generate the evidence. And then the relying party will reply with an attestation request in ad hoc EAD2, which is a single selected evidence type. And then the attester will carry the evidence in ad hoc EAD3. So right now for the new changes in version 01, we extend more possibilities. We also define the reverse attestation and mutual attestation, and then we consider both the background check model and the passport model. And we also define new EAD items for the passport model and a new ad hoc arrow to indicate when the attestation failed. So now for the attestation in passport model, the ad hoc session is still between the attester and the relying party. And the process over ad hoc is that the attester will start the attestation with a result proposal in EAD1. Like I said, it's a list of all the verifier identities from which it can relay the attestation result. And the verifier identity here is defined similarly to what we have in ad hoc for ID CRED, which is from COSI header parameter registry. And then the relier party will respond with a result request in EAD2, which is a selected trusted verifier in common with the attester. And then the attester needs to contact with that trusted verifier to obtain the attestation result and send the result in EAD3. So for the reverse attestation, one use case is that a server needs to attest itself to be trusted by the device when a device needs to share some sensitive data with the server. And here I'm also seeking input from the working group because I want to discuss about whether the remote attestation in background check model and the passport model makes sense. So in background check model, the process is that the device will trigger a new ad hoc session to the server, and server will send ad hoc message 1 with an attestation proposal in EAD1. And then the device sends the attestation request in EAD2, and server sends the evidence in EAD3. And for the passport model, it's still the device triggers the ad hoc session, and this time the server sends the result proposal, and the device will reply with the result request. And here, a concern about the attestation result is that what kind of freshness we are expected here. So I'm thinking of two options. The first one is fresh attestation result with nonce, which is that the relying party sends a nonce together in the result request. So when the attester receives the result request, it will start a new remote attestation with the verifier, and then the verifier generates a fresh attestation result and then send the result in EAD3. And the second one is that when the attester finishes the attestation with the verifier will reserve the attestation result with a timestamp to indicate the validation period. But this case, it will require a precise timing component. And then it's for the mutual attestation that we allow both the device and the server to be attested. So here we are also looking for some advice from the working group to see if both the background check model and the passport model work. So if the device has no connectivity constraints, they can perform the mutual attestation in background check model in two sides. So it will be like in EAD1, the device starts the first attestation with an attestation proposal. And then in EAD2, the server will reply the attestation proposal with an attestation request and starts the second attestation with an attestation proposal. And in EAD3, the device carry the evidence of the first attestation and then reply an attestation request for the second attestation. And then we need a fourth message, which carry the evidence of the second attestation in EAD4. And then for the device that has connectivity problem which cannot have many connections, they can perform mutual attestation in background check passport model. So the device also starts the first attestation with an attestation proposal, and this time the difference is that the server will send a result proposal for the second attestation, which is in passport model. And in EAD3, the device will send an evidence for the first attestation and then a result request for the second attestation. And then the server needs to contact that trusted verifier to get the attestation result. And here, sorry that I made a mistake for the figure for EAD4, because like this EAD4 line should be after the second green line, because for sure like the EAD4 is sent after receiving the result from the verifier. Sorry for that. And then we also define a new ad hoc arrow, which is to indicate that all the options complete successfully, but the result of the attestation is not good. So it can happen in two cases. The first one is that the verifier evaluates the evidence, but this is not in a good state. And the second one is that the relying party receives the attestation result, but the level of trust it can establish is not enough to proceed with the following actions. So the relying party will generate the ad hoc arrow and send it to the attester, and it is the application who decides how to handle with the error message. So for conclusion, we define the forward, reverse, and mutual attestation flows, and we applied it on both background check model and passport model, and we defined the new ad hoc arrow to indicate the attestation failed. And the most importantly, we are looking for input from the working group to discuss like the freshness tab of the attestation result, either with nonce or something with timestamp, and also the feasibility of the reverse and mutual attestation, and or like any other advice. So thank you for the attention, and we are also open for more detailed discussions and collaborations. You can send me the mail, and right now welcome any comments and advice.
Thanks, Mohammed.
Hi, Yuxuan. Thanks for being awake at very late night. So a quick question. So you had the terminology of forward and reverse. Is that a standard terminology, or is that something that you have defined on your own?
So for ad hoc, they have a reverse ad hoc flow, but for reverse attestation, I think right now it's new, because I want to like distinguish between the like when the server is the attester, which is the reverse attestation, and the device is the attester, which is the forward attestation. So right now, I think it's not standard. Before it's like the reverse attestation is quite new. Yeah.
Okay, so then in that case, do you define in your draft what you have defined or what you think of it as forward and backward? Do you define in the terminology section or something like that?
Yeah, like I have each section separate to define. Yeah.
Thanks.
Okay, other comments? I guess I have a question, Yuxuan, is where do you think this document is at in terms of issuing a call for adoption? Or I'm not sure if you've thought about that. It is, this topic is on our charter, so it's a charter, it's a thing we're chartered to try and address.
Yes, the charter is addressing the remote attestation using the RATS architecture, so this fits well in the scope of the charter. So yeah, this is the second time that Yuxuan has been presenting this, so I guess we could aim for adoption call soonish.
Soonish sounds precise enough. Yeah, I think that seems about right. I mean, so I would encourage people to read it, and with a view to expecting a call for adoption in the next month or two, probably before November. So
yeah, I think that's reasonable. I think that's reasonable. Yeah.
Okay, cool, great. Thanks, Yuxuan.
Thank you.
And our last presentation is Elsa. Let me just get the slides up for you. So Elsa, I can give you control of the slides, or would you rather I click through them for you?
Yeah, okay.
I'll give it to you. There you go. Okay, so we don't quite have 20 minutes. I think we've 16.
Yeah, I'll be shorter than that, so it's fine.
Thank you.
Okay, so hello everyone. Okay, no. Okay, so hello everyone. My name is Elsa and I'm going to be presenting the ad hoc pre-shared key-based authentication method that well, we're working on the implementation right now. So a bit of where are we at right now. So the draft was published on the 4th of July, and the goal of this presentation is to present the current status and the two proposed variants for pre-shared key-based authentication in ad hoc. So a bit of well, what's the motivation behind it? So the IETF Lake Working Group has identified pre-shared key authentication as a key objective in its charter. And so we're looking at, regarding the infrastructure, we're looking at billions of SIM cards which are already deployed worldwide. So by focusing on pre-shared key authentication, we can tap into this network without requiring widespread hardware replacements. So instead, we can update the software, which is significantly more cost effective. And this approach also preserves the substantial investment that has already been made in this technology. The strategy that we propose also facilitates a gradual transition to newer security protocols. So by combining ad hoc with pre-shared key, we can create a bridge between current systems and future security needs. So this allows for adoption of security measures by older devices that may not be capable of supporting the newer authentication methods on their own. This gradual approach also ensures backward compatibility while still moving forward with improved security standards. So currently, the working group has proposed two variants or solutions for including pre-shared key authentication in ad hoc. So here we have two images presenting the message flow for each of the variants, to which we refer as variant 1 and variant 2. So the main difference, it's highlighted in yellow. So it's basically where is the identifier of the pre-shared key credential sent. So in variant 1, following the approach of TLS, we send the ID cred PSK in the first message in the clear, whereas in variant 2, authentication is delayed until message 3, and the ID cred PSK is sent encrypted in message 3. So I'll go a bit into each of the proposed solutions. So regarding variant 1, we have in the left the message flow of ad hoc, and on the right we can see the message flow of this current variant. So the main differences are, first of all, we send the ID cred PSK in the first message in the clear. We keep the message 2 the same as the message flow in ad hoc, but we use the MAC instead of the signature. Regarding message 3, we remove the MAC and the signature, and we use the authenticated encryption with additional data for authentication. And then message 4 remains optional, and it's kept similar to the ad hoc message flow. There are also some modifications regarding the key schedule. So basically, these modifications include we substitute the credential of the initiator and the responder by this cred PSK. So they affect some pseudo-random keys, such as PRK3E2M and as well for E3M. MAC2 also is it's also modified since in the context we are including as well the identifier of the PSK credential. Similarly with the transcript hash, which include this cred PSK. Yeah, and the key 3 and initialization vector as well. Regarding variant 2, yeah. Oh, I see someone that has.
Do you want to jump in
raised
now,
a-
Scott, or do you want to wait till the end? So Scott's going to the mic. Yes.
Okay.
Behind you.
Scott Fleur, Cisco Systems, could you go back to slide 5?
Yeah,
That's 5, not 6.
that's 6. Yeah,
Okay.
5.
I believe that you're using basically the authentication that happens if the AED is actually able to validate. Is that correct?
Sorry, can you repeat?
Okay. And you're basically the validation is in message 3. If validation fails, the idea is that if the keys don't match,
Yes.
then that AED will fail. The problem is that that's relying on a property of AEDs, which is not standard.
Mm-hmm.
That basically an AED does not guarantee the fact whether or not you can have 2 different keys which both validate the same message.
Okay. So it would still be needed to add the MAC. Is that what?
You either need to specifically say you need additional properties of this AED or do something else.
Okay. Okay, I know that. Okay. Thank you. Okay, so continuing with the second variant. This one includes more modifications with respect to the current ad hoc message flow. So message 1 is kept the same. In message 2, we remove the MAC or the signature because there's no authentication yet to be done. And then message 3 is composed of the concatenation of 2 ciphertexts. So we have a first ciphertext which contains the encrypted ID cred PSK. And then we have ciphertext 3B, which contains the authenticated encryption with additional data. Note that here for the external AAD, we are using the ID cred PSK as well. And we're not using MAC either in this version. And then message 4 is still optional, but in this version, in this variant, we do need a fourth message in order to have mutual authentication, but it can be replaced, for example, by an OSCORE message. So regarding the key schedule, again, there are some modifications which mainly include including this cred PSK in some of the pseudo-random keys or the transcript hash. And then in addition, we have this new key stream 3, which is used for the encryption of the ID cred PSK in message 3. So yeah, this table is used to compare a bit the different variants and what are the pros and cons. So regarding the privacy, we see that in variant 1, we could say that it has lower level of privacy since the ID cred PSK is sent in the clear compared to variant 2 where we send it encrypted. In addition, in variant 1, the identity of the initiator is exposed from message 1. And both initiator and responder are vulnerable against passive and active attackers, whereas in variant 2, the identity is protected until message 3, and the identities are protected against passive attackers. The authentication timing occurs in message 1 for variant 1, whereas it's delayed in variant 2 until message 3. This also affects the early access control, which is possible in variant 1 from message 1 and delayed in variant 2. Regarding denial of service attack vulnerability, we can say that variant 2 might be more vulnerable since, until message 3, there's still no authentication. Also, resource allocation, variant 2 requires more resources to be allocated before authentication. And the key derivation timing is delayed as well. And then regarding the completeness, if we understand completeness as achieving multiple authentication and key authentication, variant 1 is complete without message 4, whereas in variant 2 we actually do need a fourth message, which again can be replaced by an underscore message. So this leaves us with, in both cases, 3 messages plus an optional fourth. And then the number of operations is similar in both, with 2 asymmetric operations and 4 symmetric operations. So regarding the next steps, we're working on the implementation of ad hoc with pre-shared key in Lakers. So the goal is to merge this pre-shared key authentication method with the already existing stat method, which uses the static Diffie-Hellman keys. And then we want to work on evaluating and comparing both variants in terms of security, privacy, operations, energy consumption, memory consumption, or latency, and then compare them also against the already existing methods, such as the signature and the static Diffie-Hellman keys. And that's all for me. Thank you.
Great. Thank you. Questions, comments? Christian?
Christian Amsus, in that trade-off between variant 1, variant 2, have you looked into whether it might make sense to send the PSK ID in message 3? In message 2, because that sounds a bit silly when you're looking into the co-op forward flow where the client is the initiator, but when the client is the responder, this might give you a middle ground of the properties and still complete with message 3 and hide the PSK from a passive attacker, but not from an active attacker, which I think is a property that variant 2 has as well. So it might be a middle ground worth investigating.
Yeah. Okay. Thank you. Yeah, I don't remember if we actually looked into this or not. But yeah, thank you.
Okay. So I guess I mean this is a chartered topic for the working group. I think in this case it's somewhat more complicated. So I don't know, Militia. It seems like maybe the right thing to do here will be to give, see, does anybody else have a different idea for how to do it? And if this is the proposal, or if we get other proposals, I guess organize an interim meeting on this topic specifically.
I think that's a good idea. So we had a very fruitful discussion during the hackathon in Paris on this, with several key participants participating in the discussions. And essentially, what Elsa has presented is the outcome of those discussions that were kind of not an it wasn't an IETF meeting, but it was still very, very focused on Lake. And so in that sense, we already had a kind of a meeting to discuss this, but having another meeting specifically dedicated to PSK authentication, I think totally makes sense. And I guess we should be aiming for a timeline, for a time frame before the IETF 121, sometime September or late September.
Yeah, I mean, I guess we can send a mail to the list saying we have this draft. Does anybody else have another draft to offer? And if we, if it turns out that this is the main thing under consideration, we can probably do something sooner in September. If there's if somebody has another idea for how to do it, then that might need a little bit more time. And,
yeah, I think that's a good idea.
I think this topic needs some time and consideration anyway, and probably some security analysis and all sorts of things. So, but it's it's a chartered item. We should progress with it, and we'll probably start that with an interim in the before November.
Sounds good. Sounds good. That's reasonable in my opinion. So what Elsa has been presenting, this is an individual submission, as you know. So we are looking forward to more. Discussion on this.
Just for information, the billions of Sims comment that triggered me anyway to say this probably needs a bit of work. So
yeah,
and I think it's good work, and it's good that we analyze these things. Any other comments on this? If not, great. So we'll take this to the list and then to an interim likely. I think that brings us to within a minute of time. Does anybody have any other business that requires less than a minute? Taro, is that business or are you leaving? Oh, Taro's gone to the microphone. Is that? He even got in the queue. Taro.
So in IEEE, we started a project to actually standardize ad hoc now to 15.4. So if there are anybody who are interested in that work, it's starting probably in the the November timeframe, or we might already have a meeting in September.
Great. So is that a new IEEE project or?
That's a new project, TG for TG9A. So it's a 15.9, which is key management for 15.4, and adding an ad hoc as one key management protocol there.
Excellent. If you could send a mail to the list with a pointer, that'd be super. Thanks, Tara. Okay, and I think with that we're at time. Thanks everybody, and we'll see you on the list and with some intro meetings and maybe in Dublin in November. Thank you. And thanks to our note takers. Cheers, Militia.
Cheers.
I guess it's late for you. I can probably have a look at the notes and send them out as draft minutes, unless you feel like staying up later.
I can do it tomorrow. It's fine.
Okay, great.
Yeah, I'll set. Yeah, I can do it tomorrow. I think the guys have done a great job of taking notes, so it's only a matter of formatting and then pushing them to the data tracker.
Go right ahead. Thank you. Thanks
yeah, I'll do it tomorrow. Thank you.
Cheers. Bye-bye. All right.